Hello everyone, I am Akanksha and this was my thesis topic where I have empirical mode decomposition, feature extraction and explainable AI for detecting mental workload. For this, the table of contents will be introduction, related works, material methods, result, performance evaluation and conclusion. First introduction. So as you know, mental workload has a growing impact on well-being and performances, and the reliable method and objective for detecting mental workload is still a challenge in the society. Before, people used to use EEG data for detecting stress. However, EEG signals are very expensive to use, so they have switched to ECG and PPG signals, where ECG is monitored through heart activity and PPG is measured through blood volume changes. For this research, I have used empirical mode decomposition for extracting features from ECG and PPG signals, and I have used machine learning classifiers and 1D CNN for classifying stress levels, and I have also used sharp explainable AI model for identifying key features which are influencing stress classification. The objective of my study was to develop a reliable framework for stress detection using ECG and fingertip PPG signals, and to access the benefit of combining ECG and PPG signals for understanding the stress responses. I have also compared machine learning classifiers and 1D CNN for identifying optimal models for stress classification, and used sharp analysis for feature importance. Next is the related work. So this table shows the previous studies on stress datasets where the maximum accuracy was achieved by author 3, and he has worked on class dataset and achieved an accuracy of 87.8% on PPG datasets using classifiers. So for next is methods and materials. First one is MOS dataset. So basically this dataset was developed for detecting mental workload, and for this dataset they have captured 4 signals. One is ECG, second is GSR, and for PPG they have calculated 2 signals, fingertip PPG and wrist PPG. For data collection, they took 22 participants where they have captured their ECG, GSR, fingertip PPG at 256 Hz. For their experiment, they provided questionnaires to the participants, and also they took the NBEC task. Basically, for the whole dataset was calculated on NBEC task, where they were given these numbers from lower level to higher level and higher level to lower level, and after that they were given questionnaires to detect their stress levels. And figure 1 shows the pipeline of the original study which was performed by the author who developed the MOS dataset. For his study, he has used HRV features while we will be using EMD features. Next is technology. So first one is empirical mode decomposition. So basically empirical mode decomposition is a signal processing technique which decomposes signals into IMFs, and this helps in analyzing non-linear complex physiological signals like ECG and PPG by isolating their oscillatory modes. Plot 2 and plot 3 shows the 30 seconds of ECG signals for low and high workload, and plot 3 shows for the fingertip PPG on low and high workload. IMFs, so IMFs are when we decompose the signals, the signals get generated into different IMFs. Basically, it means the signals get decomposed on different levels, and on each IMF the signal calculates takes out the important features from it. So this figure shows the original signal for fingertip PPG on high workload. When we need to calculate the IMF, we basically calculate the local maxima and the local minima points, and then we take out the mean of these points. Then when we need to calculate IMF1, we subtract those mean from the original signal. That is how we get the IMF1. And if we want to calculate IMF2, again we have to perform the same thing as we have performed on original signal and subtract it from IMF1. So this figure shows the 30 seconds of ECG signal low and high workload IMFs. I have calculated 4 IMFs because after 4 there was we can still decompose the signal, but the important features were not being extracted from it. So till I have applied till level 4. This is for fingertip PPG signal. And then I have used Sharp for extracting feature importance in model prediction. Then why I have used empirical mode decomposition is basically because previously HRV was used instead of EMD. However, like HRV cannot calculate from the non-stationary signals. Also, it cannot calculate if there is any sudden shift in the signal, so it cannot capture the features from it. Also, it cannot identify different patterns in non-stationary signals. So I have used EMD. For example, if there is a person who is having a sudden anxiety or stress, so his heartbeat changes, like alteration in relaxation activity changes. So that cannot be captured by HRV because of the non-stationary modes. Then is my methodology my objective was to detect mental workload using ECG and PPG from MOS dataset on low and high work scenarios. The dataset basically had 3 trials, total of 6, but 3 levels: low, medium, and high. So I have utilized just low and high for my research, and for this I have used 30 seconds window for ECG and PPG and at 256 Hz. And we first decompose the signal using EMD into IMFs, and then for those 4 IMFs I have calculated 12 features for each IMF. And for this I have utilized classifiers and 1D CNN. So for classifier, I have classified into 2 models. One is unimodal data and another is multimodal data. For unimodal, we basically take ECG and fingertip PPG separately, and like I'll explain it in the figure. If I have a ECG signal, I have classified, I have it on low load and high load. Then on these loads we apply EMD. We decompose them into 4 IMFs. For each IMF we have applied 12 features. Then we concatenate all the features we have extracted from IMFs. Then we apply classifiers on it, and whichever classifier received the highest accuracy, I have applied XAI on that. And for this study, random forest received the maximum accuracy, so I have applied XAI only on random forest. Next is the multimodal data. For multimodal data, we have combined ECG and fingertip PPG signals. And for this, I have ECG signal, the same I have calculated IMF's features for ECG, and with the same process we calculate IMFs for PPG signals. Then since it is a multimodal, we concatenate the IMFs from PPG and ECG, and then we apply classifiers on it and XAI on the model which achieved the higher accuracy. Then I have used 1D CNN for unimodal and multimodal data. Same, I have took 30 seconds of framework for both and applied IMFs. So the same process follows till IMF. We just need to replace the classifier model with the 1D CNN model in it. And next is multimodal data for 1D CNN. So again, the same process follows till the concatenation of IMFs, and then we calculate the 1D CNN. For the classified result, for ECG, random forest received the maximum accuracy of 88.64%, followed by gradient boosting and KNN. For fingertip PPG, again random forest received the maximum accuracy of 80.68%, followed by gradient boosting and error boost. For combined multimodal dataset, again random forest received the maximum accuracy of 87.50%. For 1D CNN, the results were not better than the machine learning classifiers. For ECG, it was 56.8%, and from the figures, from the confusion matrix, you can see like it has just lower accuracies. For fingertip PPG, it received 58% accuracy, and from the confusion matrix, you can see the balanced recall. For combined PPG, combined dataset, it received an accuracy of 55.1%, and it showed balanced performance for this, like as you can see from recall again. And these are the results for sharp analysis. For ECG signal, I have applied on random forest. From this figure, the first 3 IMFs, first 3 features had the most impact on the stress data set, and the last 3 or till 5 or 6 you can see we have the lowest of the features, and through sharp analysis we can predict that even if we don't use these below features, it won't impact our prediction. For fingertip PPG, again for the random forest, first 3 mean, energy and standard deviation was the highest, and for combined PPG, waveform length and zero crossing rate were highest. Performance evaluation, this table shows the comparison of my study with the other 3 studies where the other authors have used HRV feature extraction technique, and I have used EMD. They have used the classifiers, we have also used random forest classifiers, but random forest got the maximum accuracy compared to the other studies. Also they have basically 2 were done by the same author, where he has in the previous study he just used the simple signals, but in the next study he has used the outlier removal technique. For the conclusion, so proposed method for mental workload detection using ECG and fingertip PPG signal utilizing EMD for feature extraction, and demonstrated effectiveness of EMD features with machine learning models, especially with random forest classifier. Also, sharp findings confirmed the effectiveness of the features in distinguishing between low and high mental workload, and future research as if there is no research again. Thank you.